Alright. Today we're looking at division and factorisation of polynomials. Alright, so first of all, I'll remind you of division. Division by a linear polynomial. Right, there's a couple of ways of doing that. The first one we'll look at is the process of long division, which a few people like, but a lot of people don't. So if we're going to divide a polynomial, so 3x to the 4 plus 6x squared.
Is this an egg?
Yes, I should have egg next to it, shouldn't I? Egg. 6x squared plus 3x plus 33 by x minus 2. Alright, so if we are doing the long division process, the thing we're dividing into, we put under the division thing, and the thing we're dividing it by, the x minus 2, goes out the front there. Now you'll notice in this one here it doesn't have an x cubed term, so if you're going to do long division, so you don't get lost with
0x cubed
stuff, you put 0x cubed in. Yeah. And if you don't do that, then it can just get a little bit confusing. Alright, and so then when you're doing it, you can kind of set out now in columns. So anything in this column's going to be x to the 4, anything in, and so on. Alright, so we've done this before. So now we've got to divide all that that's under there by the x minus 2. So to make things easier, we just look at the x part here. So this x, to get 3x to the power of 4, we would have to multiply by 3x cubed. Now of course this factor here is not just x, but it has a minus 2 as well. So we need to bring that in. So 3x cubed times x gives us our 3x to the 4 bit. 3x cubed times minus 2 is minus 6x cubed. And so see now in this first process we've now got an x cubed term. Alright, so what we then need to do is we need to take away that to see what we've got left. So what we've got left is 3x to the 4, take 3x to the 4, which is 0, which is what we're after. And then we've got no x cubes, taking negative 6. Negative and negative is a positive, and so we would have 6x cubes. Alright, all this here is still there. None of that's changed because there's been nothing here that we've taken away from any of that. So when we start this process with the next line. So how can we get 6x cubed with x? Multiplying it by 6x squared. So 6x squared times x is a 6x cubed. 6x squared times minus 2 is minus 12x squared. And now we take away that stuff. All right. So 6x cubed takes 6x cubed, that's gone. Negative here, 6x squared plus 12x squared, 18x squared. The 3x and the 33, we haven't done anything with that. All right, so now we start with our 18x squared, so we've got to times x by 18x to get 18x squared. And negative 2 times that is negative 36x. And then we've got to take away that stuff. Zero, negative and negatives are plus, so 39x plus 33. So to get 39x, got to times x by 39. So then we get 39x minus 78. And then we've got to take that away. And then when we take that away, we get no lots of x, negative and the negatives plus, so that's going to be a whole lot. 78 plus 33, 111, is it? So what that tells us is we've got some remainders here in this time. So, what does all of that mean? Well, all of that means that 3x to the 4 plus 6x squared plus 3x plus 33, when it's divided by x minus 2, you get this with that remainder. So what do we get? We get 3x cubed plus 6x squared plus 18x plus 39 with a remainder of 111. Alright, so the remainder could also be written as 111 over x minus 2. Alright, so that's long division. Synthetic division is another way of doing it. So let's have a look at the synthetic method.
You can do the same question.
Yep, I'm going to do exactly the same question. Alright, so there's your long division method. And what I'm going to do here is the synthetic method. So for the synthetic method, x minus 2 is the factor. So for the synthetic method, what we do is we substitute x equals 2, or we use, I shouldn't say substitute, we use x equals 2. Probably. So we use x equals 2. Alright, then the way we set it up is this. So we don't need all our powers of x for our synthetic division. So with our synthetic we set up something like this. Because we're using x equals 2, we put a 2 out there. Then what we put up here is all our coefficients. So since we've got x to the 4, we'll go a 3 here because that's the coefficient of x to 4. There's no x cubed term, so we still need that. There's 6x squared terms. There's 3 x's, and then we've just got our 33 on the end. So with our synthetic division, the number in the first cut here, the number that we have, we bring it down. Then what we do is we go 2 times 3 and we put the answer there. So 2 3s are 6. So we put the number 6 here. Then what we do in the columns, no, we add. So for synthetic division we add. Because we're using x equals 2 here, rather than minus 2, we end up adding. So it's a little bit different here. Over in our long division we took away, but with these we add. So 0 plus 6, and then we add. So we add those. And then we repeat that process. So 2 times 6 is 12, 12 goes here. 6 plus 12 is 18, that goes there. 2 times 18 is 36, so 36 goes there. We add 39, 2 39s are a bit, 78, aren't they? And then we have 111. So up the top, this was our x to the 4, x cubed, x squared, x, and our constant. And down the bottom here, this is now x cubed, x squared, x, constant, and remainder. So what do we get? We've got 3x cubed plus 6x squared plus 18x plus 39 plus our remainder. So either of those you can use. Doesn't matter which one. Lots of people prefer the synthetic. All right. Anything in that anyone wants clarifying? No? All right, now the next one, so that was a linear polynomial, so you've got 2 ways you can do it. This next one, unfortunately, you have to use long division. So if we're dividing by a non-linear polynomial, So that's if we've got, say, an x squared term or higher. So if a question on this is in exam 1, you have to do it by hand.
And we do that?
And I will show you how to do that. Because in exam 1, you don't have your calculator. And so the synthetic division won't work for a nonlinear, so we've got to use long division. All right, let's have a look at an example. Yeah, so x take 2 and then we just put a 2 there. So, but if there's x squared term in there, we can't, there's no shortcut that we can do.
Because the x will be
Because there's an x in there as well. All right, so let's have a look. So we're going to divide 3x cubed minus 2x squared plus 3x minus 4, oops, by x squared minus 1. Now you'll notice here our x squared minus 1, no x term in it, so what we need to do is we need to write x squared minus 1 as x squared plus 0 lots of x minus 1. So we set it up just like we did before. 3x squared here, cubes I should say, minus 2x squareds plus 3x minus 4. And we're dividing it by x squared plus 0x minus 1. And we need the 0x for similar reason before, so we don't lose stuff. So we do the same as before. We've got an x squared here, we need to get 3x cubed, so we need to multiply x squared by just 3x. So 3x times x squared is 3x cubed. And then we multiply the 3x by each of these others, so 3x times 0x is 0 lots of x squared. 3x times negative 1 is minus 3x. And then we take that away. So 3x cubed, take 3x cubed to 0, minus 2x squared, take nothing is minus 2x squared. Negative and negative is plus, so that's going to be plus 6x. And the minus 4 still there. So the next step, start with the x squared again. So to get minus 2x squared, we just need to multiply it by negative 2. And then the minus 2 by each of those. So minus 2x squared, minus plus 0 lots of x, plus 2. And then we've got to take that away. So 0, 6x, and minus 6. And that is as far as we can go with this one. All right, because x squared here, and we've just got x there, so we've got a remainder, yep. So what is it? It's 3x take 2 plus your remainder, which is 6x minus 6 over x squared minus 1. We don't need to put the 0x in there, that was just in there to help us with our calculation. So if you've got exam 1, that's how you do it. If it's on exam 2, you wouldn't use your time doing that, and I would doubt that they would actually even give you the space required. So on exam 2, you would use your calculator. So exam 2, you would use the calculator. Now, with our calculator, sometimes it won't give us answers in a form that we like. So what you need to do is you need to do this. You need to go to your action menu. From your action menu, you then need to go to transformation. Then from transformation, you need to go to fraction. And you want it written as what they call a proper fraction. All right, so you could do this, you could do it without all of that. However, it's not going to give it to you in the form you want. So you'll then get prop frac. And then inside the brackets, the way you write this division is like this. So you need the fraction template, the number you're dividing into, or the thing you're dividing into, goes on the top, and the thing you're dividing it by goes on the bottom. And when you do that, what do you get? Anyone done it? Yeah, I think you get that. Or a version of. Anyone got it? Yes, no?
Yeah, you get that. Or sometimes it's swapped, like the remainders in front.
Sometimes, yeah. Anyone got an answer? How's your calculator write it?
3x plus 6x over x to the power of 2 minus 1. So the first remainder, and then it goes minus 2 over x to the power of 2, take 1, and then plus 2 at the end.
I've just got 3x plus 6 over x plus 1 minus 2.
Yeah,
That's what I'm
Okay.
Plus 6 over x
3x plus 6 over x
Over.
plus 1.
plus 1.
The plus one's
Six,
over.
the
I did the
plus
exact
1
same.
is underneath
I
the
did the
6
exact same with with the the x, x. it's something different.
Clear variables.
plus 1, yeah?
And then
Minus
Take
2.
minus 2 at the end.
at the.
Is that the same thing?
Yes.
All right. Is it the same thing? Let's have a look.
Yeah, it
It is the same thing. Because what could have I...
3x minus.
This bit here, the 6x minus 6 over x squared minus 1. Common factor of 6, yeah? Dots. That factor cancels.
Right.
No.
So there it is there. So yes, it does do the same thing. But if you don't use this prop frac, it's not going to give it to you in that form.
Wrote that in exam 1.
Yeah, you probably should.
So they would they give you a mark for it?
Yeah, it's, probably, yeah. Well, you'd have to read the question, because if it's just asked you to divide, then
Technically, that's right.
then that's an answer. That's the answer, isn't it? But if they ask for the answer in simplest form, then you would have to do that, wouldn't you? But just be aware your calculator sometimes. So like it's put it in that order there. So it's just put it in a different order. So just be aware with your calculator, the programmers. May or may not have written the program to give you an answer. Alright. I would think the exam one would not be too tricky because it's only an hour. You never know.
They could try and trick you though.
They could, you never know, you've got to be prepared. Alright, remainder and factor theorems. We've done these before.
This is like a normal exam, like 2 hours plus the 15 minutes reading time. I'd assume. So.
Is the hour for exam 1 including or not including reading time?
Is it really? I think it's excluding.
They're both 15 minutes reading time for both, and then an hour writing time and 2 hours writing time. Alright, remainder theorem.
Yeah, you wrote. Yeah, isn't that like P? Yes. And it's P, and then you put the remainder thing in the brackets.
Kinda.
Oh, shit.
You're kinda right. Can't spell divided. There we go. Alright, so if it's divided by beta x plus alpha, where beta and alpha are numbers, then you find the remainder by putting negative beta on alpha. What does that mean? Here's an example. Egg. Alright, so if we're going to do synthetic division or long division to divide that in to find out what the remainder was, it's a time-consuming process. So remainder theorem, so the way you think about it is you can say, okay, so if 2x plus 1 is equal to 0, and then I rearrange by taking 1 and dividing by 2, you get x equals negative a half. So the remainder...
Sorry, is that X or a fish?
It's a fish, it's an
So it might have been
alpha.
like the proportionate.
It's an alpha. It's
Nothing.
an alpha.
Sorry, just is it
Alpha and
X or
beta. Alpha and beta. Which are numbers. And in this case, alpha's 1, the beta's 2.
Why?
Oh, just because I've used those symbols because that's what they're using in the textbook. So, what that means is that P of negative a half gives the remainder. So when we put in P of negative a half, so we go 3 times negative a half cubed plus 2 times negative a half squared plus negative a half plus 1. And we do that calculation, and when we do that calculation, we get 5/8. So rather than doing long division or synthetic division,
Just to find the remainder.
to refine the remainder, that would be handy. Because if we're going to do long division or synthetic division, we're going to end up with some fractions in there, quite clearly. We've got fractions on here. Now, if I had have got 0 as that answer, what could you tell me? Not much.
With the remainder.
So the numbers, right?
Wouldn't the remainder be 1?
Remainder be 1.
Because that's the only number that's not being times by.
So it goes in. So what this is saying is that we've got a remainder, so that doesn't go into that
yeah,
evenly.
If the remainder was 0, not if the.
So the remainder is 5/8, so that tells us that 2x not plus 1 doesn't go in evenly. What if the remainder was 0? Or something has a remainder of 0? It goes in evenly, and so if it goes in evenly, that means it is a factor. Exactly. And that is what's the factor theorem. So the factor theorem says if x minus alpha is a factor of p of x, then p of alpha is equal to 0. So if you have a remainder of 0, so, and then of course conversely, if you've got p of alpha equaling 0, then the other way around, x minus alpha is a factor.
Ah, okay.
So we know something's a factor of this polynomial, we get a remainder of 0. If we know the remainder when we put some number into the polynomial and we get 0, then we know that that's a factor. So we can work it both ways. Alright, let's look at some egg.
Can I please go get a tissue?
Sure can.
You know really are.
Try in the office there. Oh! Be handy if they had written on the boxes what colours they were. All right. So we're told that these two things are factors of this. All right. So if they're factors of that, what we know then is from x plus 1, p of minus 1 will be equal to 0. And from the x minus 2, p of 2 will be equal to 0. Because we were given that they're factors. So if we're given their factors, we know the remainder is 0. All right, so let's put that in. So p of minus 1, 6 times minus 1 to the 4 minus 1 cubed plus a times minus 1 squared minus 6 times minus 1 plus b, and that's equal to 0. And if I do some working out here, I'll get 6 plus 1 plus a plus 6 plus b equals 0. And if the number bits together, you get a plus b plus 13 equals 0. And the p of 2, put them in. And when I work out those numbers, I get only 6 minus 8 plus 4a minus 12 plus b. And combining those numbers, you get 4a plus b plus 76 is equal to 0. And then what are we going to do? Solve simultaneously. And when you solve simultaneous, you get that a is equal to negative 21 and b is equal to 8. Ah, yes. Oh, yes. All right, these next two things. Need to have them in your bound reference. Need to know where to find them. So extremely handy.
Really.
Sum and difference of cubes. So we've got a dots, which is sum and difference of squares. This is sum and difference of cubes. So for a sum, if you have x cubed, it's the wrong way around, you twig, plus a cubed then there is a pattern, and the pattern is this. One of your factors is x plus a. The other
Doesn't it keep going? And it's like, oh, I don't know what it is. Then.
you don't know what it is.
I don't know what it is, but I do.
That's enough of this
What did you say?
Stop. It's that.
Expletive.
Is what it is. And the difference one is very similar. So if we have x cubed minus a cubed, what's that? Alright, so as I said, you need it in your bound reference and you need to know where to find it. It's probably not something that you're going to remember. No, it's something that I don't remember. But if you know, you can recognise the difference of cubes and then you know where to find it, then that is handy. So for example, if I want to factorise the following. Alright, 125a cubed minus b cubed. So it's got the negative here, so we're looking at the difference one. You know about the number 125. 5 times 25, and 25 is...
5 times 5.
So 5 times 5 times 5 cubed. So what we've got, 125a cubed minus b cubed, effectively, we've got 5a cubed there at the front, minus the b cubed. So when we factorise that, here we're now, the pattern here, it's got x cubed, so rather than x, we've got 5a. 5a, and instead of the a up here we've got b, so 5a minus b. Then in the next one it's the x squared, so it's the 5a is squared, so that'll be 25a squared, plus the 5a times the b, plus the b squared on the end. That is it. Yes, Sarah.
You said like factorise 125, and then there's up the top how it says b cubed, and then on the second row it's b squared.
Oh, so I've written that incorrectly then, haven't I? Thank you. For all of you, like and subscribe. Thanks, Sarah.
No worries, anytime.
All 6 of x. You've got to put your Patreon link in there.
I'll be paying out though. Alright, now this next thing.
Where do you catch up?
Alright. This next thing is a thing called the rational root theorem.
That's pretty epic.
Alright. What does it say? This is what the rational root theorem, this is what it says. So it says if px is some polynomial, power n, and some constant down the bottom there, then what we are concerned with when we're using the rational root theorem is we're not concerned with all of this stuff in the middle. The things that we're concerned with is our constant on the end and our coefficient of our first one there. So remember when we're doing a factorisation, so we've got 2x squared plus 6x plus 4, for example, and when we're doing that, and we do that with our synthetic division, remember it's these two numbers here that we're interested in. So this is just an extension of that. So if we've got more powers of x, it's not the stuff that's in the middle that's important when we're finding the factor. It's what the number on the end and the number at the front. All right. So it's like, you know, with this here, the number on the end, the number in the front, they're the important things. So same here. The number on the end, the number in the front. It's important. So, the number on the end. So alpha is a factor of the number on the end. Be a factor of. Be a factor of.
A's and alphas.
All right, so we're looking at the numbers on the end. Remember when you first did polynomials, so x squared plus 5x plus 6, what did we do? We looked for factors of the number on the end first, didn't we? All right, so it's looking at the same thing. So we're looking for factors of the number on the end. The other thing we need to look at is we might have a number on the front. And so beta be a factor of the number on the front. Now, and this is what is going to help us when we get to it. And these factors of these things here, we want the highest common factor of them to be 1. In other words, effectively no common factors. Not really anyway. Alright, so that's going to narrow things down. Then, beta x plus alpha is a likely factor of px. So it's kind of a bit that trial and error kind of method, but being a bit smarter than just trying any random stuff. We're going to try some particular stuff. Alright, so let's have a look at an example. I'll let you get that. Alright, so rational root theorem to factorise. So the rational root theorem says we need to look at now first coefficient and our number on the end. And we need to look at factors of those things. So, the number at the front, the a to the n, an, is equal to 3, which is 3 times 1. Now, if in this case with this first one, where one of the factors here of this coefficient is 1, we don't really need to consider that one. All we really need to consider is the other one. Alright, so from this, beta equals 3 is all we need to consider. Alright, the number on the end, which is our A0, that's -5. Now -5 we can get in a few different ways. So -5, factors of -5, well, it could be 1 times -5, -1 times 5, be either of those, couldn't it? So what we need to then consider then for alpha as being plus or minus 5. So the plus 5 will go with the -1. Or minus 5. And the minus 5 goes with the positive 1. So these are factors. So what do we need to consider? So what we need to do is we need to try some things. Because it says here, we've got a likely factor. So what are we trying? We're trying P of alpha over beta. And in this case, our beta is always 3. And so we've got 4 options here. So we want to try P of -5/3, P of 5/3, P of -1/3, and P of 1/3. So we've narrowed down however many possibilities down to 4 options. And we've used our first and last numbers to narrow those down. So because I've done this earlier, I know that when I try the first one, P of -5/3, when I do that, I get 0. Now, with these others, you might not get 0, so then you've got to work through to find out which one it is. If you're lucky and get the right one first up, you can stop there. So, if -5/3 is equal to 0, what is then the factor? What's the factor associated with that? How do we figure out what the factor is associated with that? What's this -5/3? What does it represent? What value? What value is that?
3x.
Isn't it x, aren't we? Didn't we put x in? -5 on 3, didn't we put it in for x?
So it's x,
So if x is equal to -5 on 3,
x plus 5 on 3 equals
3x plus
3x
Plus 5.
is -5, 3x plus 5 equals 0. So 3x plus 5 is the factor.
Oh.
Now the question's asked us to factorise. We found out what one factor is. To find out what the rest of the stuff is, what do we need to do? We now need to divide px by 3x plus 5, and we can do that using synthetic.
Running out of...
You're killing me, man.
3, 8, 2 and -5. I know, it's terrible, isn't it? So the number we're putting here is this one, our -5 thirds. 3 comes down here, -5, so that's a 3. -5, so that's a -3. And 5, so that's a 0. Good. So that then means that P of x can now be simplified to this factor, 3x plus 5, and the other factor, this down here, these are our coefficients, 3x to the squared. Hmm?
That has to equal 0, to find
It does have to equal 0. Oops, I've made it.
what happened?
I've done something, I've written this wrong. Written it wrong, sorry. Because we put 5 thirds on, so it's x plus 5 thirds. That's what we've used as a factor, sorry. Yeah, you've got to make sure when you write that there, you use this, not this. What do you notice about that there?
You could take out 3.
You can take out a 3. You get that? Then, if we multiply that 3 into here, then we get our factor. Sorry, I've got ahead of myself
How
before.
does this make any sense to you?
What? It's logical. I don't really understand why you're using the 5 thirds up there, but I mean, that's what it is.
Well, 5 thirds we use here because we're using the x value. We're putting the x value into that
Why is it
to get our.
plus?
So if we're putting the x value, that this is it's like x equals -5 thirds. So x plus 5 thirds is equal to 0. And so that's what goes here.
Yeah,
Because the synthetic division, you know, that's synthetic division, it's not actual division, so, well, yeah, we're kind of using it to help us with the division. It's a bit like the trick method with the factorisation, it's not actual factorisation, but it's just something we use to help us. And the trick method doesn't work if you've got a common factor. So, yeah, so that's kind of an anomaly of of the synthetic process. All right, this one here, we've been asked to factorise it. So this one here we need to factorise, and this one here you need to complete the square. I won't do it for you. So complete square. So if we complete the square on that, then what you end up with is the following. You then end up with (3x plus 5), and then two factors which are x plus a half plus root 6 on 2, 5 on 2. And x plus a half minus root 5 on 2. That's our...
Can you show us the...
You want me to do the complete the square for you, do you?
Nah, don't worry about it.
I can do it, Ben. I'm just trying to save some time.
Nah, don't worry about it.
I'll come and see you later.
Alright.
All right. That's it. 4D. And then I think we'll work on this tomorrow too.
The answer is here.
All right. Don't forget, like and subscribe.